Hey everybody, welcome to the Unit 1 Section 4 notes. Let's go ahead and jump right in. In this first section, we're talking about a ray. A ray is a part of a line. It has one endpoint and extends indefinitely in one direction. So what does that mean? It means if you were to look at this point, this would be the endpoint, M. And you just need one other point to name the ray. So you could use O or you could use P. That's why this says ray MP or ray MO. There are a couple different ways you could see it. Um, if uh, if we're able to, we'd like to type it in with the little ray symbol above it, but it's not necessarily needed, which is why you see it just as MP or MO. These are all acceptable forms, but you can see that it extends indefinitely in one direction. So how you name this is you look at the first point, like the anchor point, right? The M, and then use a point that comes after it, and that's how you name your ray. So that's why we can say MO or MP. It doesn't really matter because the line is just going off indefinitely. Okay, you know if it's going indefinitely if it's got the little arrow. Okay, if it doesn't have this little arrow, then it might stop and it might not be a ray. It might just be a line or a line segment. Okay, so Um, I pretty much said this. Rays are named by stating the endpoint first and then any other point on the ray. The ray shown blank be named as OM because O is not the endpoint of the ray. Okay, so what it's saying is the ray shown cannot be named OM because O is not the endpoint. Okay, um, so I'm just going to write the word cannot right there. This next section or sentence says blank blank are rays that share the same starting point but extend in opposite directions. So your keywords are rays and opposite. So the vocabulary here is opposite rays. And so if they're rays that extend in different directions, such as J, H, and then J, K, those are going in opposite directions, but they're on the same line, so we say they're also collinear. Remember, collinear just means you're on the same line. All right, so what I just said goes right here. JH and JK are opposite rays. And in this next section here, an angle is formed by two non-collinear rays that have a common endpoint. Okay, so an angle is formed by these two rays. You can call this ray XY and ray XZ. We say they're not collinear because the line did not bend in any sort of way. Okay, they just share the point X. They don't share a common line. Remember, a line needs at least 2 points. All right, so if they only have 1 point in common, then they're just sharing a common endpoint. All right, so the rays here, ray X, Y, and XZ, they can be called the sides of your angle. All right, and then the base of your angle, that point X, that's called your vertex. All right, that's your vertex of your angle. Okay, you can name any angle by several different ways. All right. And it says if only one angle exists. So we can call this angle right here multiple names. If you were to say vertex only, meaning you can name an angle just by that vertex point. So I'm just going to call this is the angle symbol. It looks kind of like a less than symbol, but it's supposed to be like flatter, but I don't have the best handwriting. That's angle X, okay? You can also see that there's a little 3 tucked inside. If there's a little 3 right there, it's naming the vertex, okay? So instead of using that point X, we can call this angle 3, okay? You'll see a lot of angles numbered like that, or named like that, I should say. You could also name the angle by using the points on its sides. Just always put that vertex point in the middle, okay? So we can call this angle YXZ, or I can call it ZXY if I read it from bottom to top. Either one is totally acceptable. Like I said, just make sure you have that vertex point in it. And I couldn't say Z3Y, that doesn't really make sense. If I'm naming it using the points, um, then I have to use all the points, not a couple of the points and then that number that's typed inside. I hope that makes sense. Okay, so this sentence here just reiterates what I just said. The vertex must be the middle letter of the name. An angle divides a plane into 3 distinct parts. So this here is a plane, this little parallelogram looking shape, all right? And the first bullet point says points Q, M, and N lie on the angle. Points S and R lie on the interior of the angle. So just think about what the angle is eating, I guess. And so if it's not in the interior or lying on the angle, then it's going to be on the exterior, which is what points P and O are doing. They are outside the angle. It is not eating those points. So this final example on this page, we have this little diagram, this little map. It says a map of a high school is shown below. You can see that the hallways are creating some lines and some angles. So in section A, it says name all the angles that have B as a vertex. Okay, so what has B as a vertex? So we're just going to focus in on this right here. I could go like this, A, B, D. I could go D, B, C, or I could call it D, B, K, or D, B, L, because those are all collinear points right there. Let's see here. I could also use those numbers, right? If you see a little number tucked inside of the angle and it does not have a degree symbol next to it, then it's naming that angle. So angle 1 uses B as a vertex and angle 2 uses B as a vertex. So I went ahead and I listed it. I just stacked these together, DBC, DBK, DBL. Those are all technically the same angle, just different ways of naming it. And then I wrote or angle 2, okay? Next one, B, says name all the sides of angle 3. So we look at angle 3 here, all right? And so the sides, you could be like, all right, my sides are this side, ABC, and then this side, CE, all right? That's using angle 3. So I can call the first side, it's got 3 points in it. I can call it side AC or side BC, all right? I guess you could call it CB or CA, but I think since we like to try and keep alphabetical order when possible, so I'm just going to call it side AC. I changed my mind and I went ahead and I wrote both of them, AC or BC, and then of course CE. On part C, it says, what are the 3 other names for angle GHL? So let's look at GHL here. So GHL, all right? So we need to think of some other names. The first thing I see is this. It's angle 7, okay? Because that's where the H is. H is in the middle. So that's where we look at the angle, the vertex. By the way, since that's in the middle, we could also call it angle H. And then the last combination would be to just go in the reverse order. Rather than saying GHL, we're going to go LHG. Lastly, it says name a point on the interior of DBK. So DBK, you have D here, B there, and K there. All right. If it's on the interior, then it's eating it. So it's only eating 1 point, and that's point E. In this next section, we're going to classify angles as being right, acute, or obtuse. You can see that right angles are exactly 90 degrees. Acute angles are going to be less than 90 degrees. And obtuse angles are greater than 90, but technically we say they're also less than 180. Okay, because 180, if a degree is 180, then it's a perfectly straight line. Okay, and the reason why straight lines have a degree of 180 is because if you think about a circle can travel 360 degrees. So if you have a straight line running through the middle of that circle, it is only going to travel half of the distance. So what's half of 360? 180. So using this diagram, we're going to classify each angle as right, acute, or obtuse. And since we see an angle here is given as a right angle, um, and then we're able to see that this is a straight line, we're able to, we have all the information we need to move forward, okay? So letter A says angle MJP. So we're going to go MJ to P. That's a right angle, okay? It's clearly 90 degrees at that vertex. Letter B, angle LJP. So LJP, that is going greater than 90. So greater than 90 is obtuse. And then lastly, we have angle NJP. So NJP, that is smaller than 90. So that's an acute angle. So here we have another vocabulary term. It says a ray that divides an angle into two congruent angles is called an angle bisector. So if you think about that prefix of bisector, bi means two, sector like sections. So it's in two sections. So if it's a bisector, it's in two equal sections. It's basically cutting that angle in half. So let's look at this little diagram here. It says if YW is the angle bisector of XYZ, then point W lies on the interior of XYZ. Yeah, point W is on the interior of that, okay? And so since this is the WY line is, or YW, is the angle bisector, that means we have two congruent angles. Angle XYW is going to be congruent to angle WYZ. Okay, that's all it's saying. So anytime you see a picture with these little, see the little red circles, or what it is it's marking the angles as congruent. Okay, so if I were to draw these angles separately, I could do that, and then I could draw this one over there. I don't have to connect them. And if I have that little arc right there, it's saying that, hey, this angle here is congruent to that angle there. Okay? And then it's clearly labeled as 80, just to avoid any confusion. So you can definitely tell that they're both congruent there. All right, example 3. In the figure, ray KJ and ray KM are opposite rays, and ray KN bisects JKL. If the measure of angle JKN equals 8x minus 13 and the measure of NKL equals 6x plus 11, find the measure of JKN. So the little m by the angle symbol means measure, okay? So they gave us a lot of information. Let's go ahead and label some things, okay? So KN is our bisector, right? KN is our bisector. And what is it bisecting? It is bisecting the angle JKL, okay? So basically that means this angle segment is congruent to this angle segment, all right? And it just so happens that it's giving us the measure of JKN and the measure of NKL, okay? So that means the other angle LKM, you can just ignore it, all right? Yeah, let's finish labeling this. If measure of JKN equals 8x minus 13, and NKL is 6x plus 11. Well, we'll figure out what x is, and then we'll actually figure out what the angle measures as well. But since we know that these angles are congruent, we're just going to set those two statements equal to each other. So I'm going to just write 8x minus 13 equals 6x plus 11. Okay, so I see that 6x is smaller than 8x, and it's positive. So the opposite of that would be to make it negative. So I'm going to subtract it over to the other side under the 8x. I like to keep my x's positive when possible, excuse me. So I have 8x minus 6x is 2x. If I bring down the minus 13, it's going to equal 11, okay? So I have all my x's on one side. That means I have to get all my constant numbers, the numbers without a letter, to the opposite side of the equal sign. So I'm going to have to take that 13 and opposite that. So minus 13 opposites the plus 13. And I'll plus that to the opposite side. And I'll bring down that 2x. So it's going to say 2x equals 11 plus 13 is 24. And I know that 2x means 2 times x. So if I were to get rid of the 2, I would have to do the opposite of that. And the opposite of the 2 would be, or multiply by 2, would be divide. And so I'm going to divide 2 to both sides. And 24 divided by 2 is 12. So x equals 12. Okay? If we were to take this one step further, which we need to because the question does say find the measure of angle JKN, we just have to plug that in. Okay? JKN, if you were to look at this, JKN is that 8x minus 13. Could you plug it in the 6x plus 11 because they're congruent? Yeah. But just because JKN is given as 8x minus 13, I'm going to plug in 12 for x into that. Okay, so I'm just going to substitute 12 in for x. So it says 8 times 12 minus 13. So what's 8 times 12? That's 96. What's 96 minus 13? That's 83. And that's my final answer. Final example, in the figure, ray BA and ray BC are opposite rays. Ray BD bisects EBC. Okay, so I went ahead and I labeled that information. If it bisects it, then EBD is congruent to DBC. And it says measure of EBD equals 2x plus 20, and measure of angle DBC equals 8x plus 2. So that means we just know that they're equal to each other. So that means we're going to do it pretty much the exact same way as example 3. We're going to take these two expressions, 2x plus 20 and 8x plus 2, and set them equal to each other and just solve for x, and then we can plug it back in to find the angle measure. Okay, so I see that 2x is smaller than 8x, so since it's a positive 2x, I'm going to make it minus and get it to the other side, and then that means I can bring down this 20 equals 8x minus 2x is 6x, bring down the plus 2. Okay, the plus 2 is a constant number, so I should get it to the other side of the equal sign. And so that means I'm going to minus that 2 over. And I get 20 minus 2 is 18. 18 equals 6x. Okay? So 6x means 6 times x. So the opposite of that would be to divide both sides by 6. And 18 divided by 6 is 3. So I get x equals 3. Or I guess it's the way I was writing this, it says 3 equals x, which is the same thing, okay? So we need to find the measure of angle EBD. So that means I just need to plug it into this 2x plus 20, okay? Measure of angle EBD is 2x plus 20, but I'm saying, hey, x was 3, so 2 times 3 plus 20. 2 times 3 is 6. 6 plus 20 is 26. So measure of angle EBD equals 26 degrees. So that's going to wrap up this video. Thank you for watching. I hope you learned something, and goodbye.